Okay, so we're going to do the same idea. We're going to find the area of our regular polygon, but we're going to do it with special right triangles because some of our polygons are going to lead us to special right triangles, which we should then memorize all of our, or have memorized all of our 30, 60, 90 and 45, 45, 90 rules. So we look at our shape. First, we need to identify what kind of shape is it. So we have 1, 2, 3, 4, 5, 6 sides. We are dealing with a hexagon. So 6 sides. So this question is going to kind of lead you through some of the things we need to find. The first one says, what is the measure of the angle labeled x? What is the measure of the angle labeled x? So we have to remember, first we need to find our central angle. Remember that central angle is going to connect both of these together. So all of it is our central angle. And for central angle, we take 360 divided by the number of sides, which is 6. So that gives us a central angle of 60. But I'm going to take that central angle and half it because the apothem, remember our apothem, he's right here, bisects the angle. So we're going to cut it in half. So I'm going to take 60 degrees divided by 2, and we are going to get 30 degrees for x. So our angle is 30 degrees. So I have a right triangle with an angle of 30 degrees. We have a right angle because the apothem hits at a perpendicular. So I have a 30, 60, 90. So this one right here is 60 degrees. So y, we need to solve for y. Y is going to help us find the sides of our polygon. If you remember, the apothem, which is 6 feet long, bisects the sides. So these two pieces are congruent. So this is also y. So in order to find y, I need to look at y is across from our 30. So I'm going to set up my table. Just do it right here, 30, 60, 90. We have 6 feet, which is across from your 60, which is, s root 3, which is 6, and then s and 2 times s. Across from our 30 is y, so I'm going to put y here and set it equal. And then you could also, you don't need to, but you could find the 90. You're not using the radius for this question, so it's not necessarily needed. So since 6 is my s root 3, I'm going to set those equal to each other to try to isolate s by itself. I'm going to divide by root 3, divide by root 3, and these cancel out. But I'm going to need to multiply by root 3 on both sides as well, on the top and bottom. So this becomes 6 root 3 over root 3 times root 3, taking it back, is equal to just 3. And then we can simplify. 6 divided by 3 is going to give us 2, so 2 root 3. So y is equal to 2 root 3. If y is equal to 2 root 3 and one entire side length is 2 times y, then one side length is 4 root 3. Next, I need to find my perimeter. So for the perimeter, what color do we want? Rainy green. For the perimeter, we are going to take 1, 2, 3, 4, there's 6 sides, times my 2y, which is representing one whole side, and multiply them. So 4 root 3. Remember, we only multiply with our radicals outside with outside, inside with inside. So the 6 and the 4 are going to get multiplied together, and the root 3 doesn't get multiplied to anything. It just hangs out. So 6 times 4 is 24 root 3. So my perimeter is 24 root 3. So finally, my area, we are going to take 1/2 times the apothem, which was 6 feet, times 24 root 3. And again, I'm not going to actually divide that root 3 out at all. We're just going to, or multiply it through. It's just going to hang out there. So I take 6 times 24 times 1/2, or divided by 2, and we get that the area is 72 root 3, and we're talking about feet squared. Now, if I asked you to round this to the nearest tenth, then you would multiply that root 3 through in your calculator. But unless we do, don't do that. Okay. And moving on, we're going to ignore that this is the nearest tenth. I'm going to go through one more example for you. So I have a polygon here. The first thing I want to identify is what kind of polygon it is. I have 1, 2, 3, 4, 5, 6, 7, 8 sides. We have 8 sides, so we have an octagon. An octagon. So 8 sides. So then it asks us, what is the measure of angle FHE? So FHE is our central angle. So we're going to take 360 degrees and divide it by 8. And that gives us 45 degrees. So it's 45 here at the top. But then when we take into account what HG does and try to look for angle FHG, this guy right here, we're going to divide that by 2. So that central angle is cut in half, and it is 22.5 degrees. Alrighty. So then I need to find FG. So it tells us FE is 12. So from here to here is 12. And we know that HG is our apothem. So that's going to bisect the sides. So these two are congruent. So FG is going to be 6. Now, if I wanted to, I can use this information to solve for our apothem and then find the area of our polygon. But I'm going to leave that to you.